All right, so welcome to this workshop on how to make a Finch robot remote. I'm Tom Lowers, the founder of BirdBrain Technologies. I'm joined today by Terry and Aparna. Terry, do you want to introduce yourself for a second?
Yeah, hi, it's Terry Kelly. And I am a computer science teacher from Bishop Ireton High School in Virginia. I teach Introduction to Programming, which is either in Alice or Java, and a PCSA, as well as a dual enrollment class. And I really wanted these Finches to work, so that's why I joined up with Tom to show you guys what I've done and hopefully encourage you guys to do it too.
So Terry has been beta testing using the Finches remotely with Java programming. And so that's something that we're actually showing the world for the first time today. And we've also just put up a tutorial about it. So I'm excited to share that. It'll work with both Java and Python. And Aparna, do you want to introduce yourself?
Hello, everyone. My name is Aparna Brown, and I'm the Director of Operations at BirdBrain Technologies, which means I do a little bit of everything because we're a small company. And I am going to be sitting on the chat today, answering your questions, sending you links and other information that you need. But before we get started, Tom, I am not set up to see the chat, it turns out. Somehow I'm logged in, so I'm going to let you switch that over to me.
Okay, I will make you the host, and you'll also need to, I think, allow people to get into the waiting room. So there we go. Okay. All right, so let me share my screen here. So we are going to talk all about making the Finches into remote robots. So I'm going to talk very briefly about the Finch Robot 2.0, and then a little bit more extensively about what remote robots are. And then I plan to do a live demo of how to make the Finch remote in NetsBlocks. Hopefully it'll work. It's always tricky when things are done live. And then Terry will lead you through her setup in terms of the cameras and arena that she has built for her students to program robots remotely. And then we're going to use that setup to do a quick demo of using the Finch remotely with Java. And after that, we'll have some questions, hopefully have a little bit of time for questions. So, all right, so the Finch Robot 2.0. So the Finch was originally designed in the late 2000s at Carnegie Mellon, and it was designed to engage students in computer science education. At that time, it was really focused on the high school and college part of computer science education, because if you remember 2009, we weren't necessarily talking about coding in elementary school. The Finch 2.0 kind of takes that mission of having an engaging artifact, a physical artifact that students can program, and extends it from kindergarten to college. So it's all about learning computer science and computational thinking at any age. It integrates about 10 years of feedback from the original Finch robot being out in the world and gathering feedback, gathering experiences with students and teachers. And it takes a low floor, high ceiling approach to computer science education and to supporting computer science education. And what I mean by that is, we have environments that are icon-based that students as young as 4 or 5 can use to program the robots and learn some computational thinking. We have several different blocks-based environments for tablets and laptops where students can kind of explore computer science and computational thinking concepts without worrying about syntax, but really going pretty deep. I mean, some of these environments let you do things like recursion, make lists and arrays, crunch data. So they really can go pretty deep in the block-based environments. And then we also have support for Python and Java programming so that you can take this into an AP Computer Science A course or even a college level course to do some interesting computer science problems with. The Finch is now available. The Finch 2.0 is now available, and it costs $139. So just to, oops, let me go over here. Oh, sorry, went one slide too far. Just to tell you a little bit more about the hardware of the Finch robot, what it looks like. It obviously has 2 wheels. It can drive around. Those wheels have encoders, so you can tell it to drive a certain distance, like go 20 centimeters, turn 90 degrees. That allows it to draw shapes. There is a centrally placed marker holder so that you can put a marker through the Finch and have it, have it actually draw. In terms of other outputs, it has a full color LED in its beak, 4 full color LEDs near its tail, and then a grid of 25 LEDs in its tail that you can use to display emojis, characters. You can print words or letters on them. And then finally, it has a buzzer, so it can play music, play a lot of 8-bit music, 1980s Nintendo style music. In terms of the sensors, in addition to the encoders, it can track lines, so it has downward facing line sensors. It can avoid obstacles using its distance sensor. It can track a flashlight beam using its light sensors. And then it also has a 3-axis accelerometer, so it can tell how it is oriented in space. So you could make like a musical instrument where as you tilt the Finch, it'll play different notes. It has a compass, so it can always drive, north or west. And then it has 2 buttons on the Finch's tail as well. So that's a little bit about the Finch. So the idea of remote robots really was, I guess, inspired by the necessity of the pandemic. Obviously, this past year, it has been very difficult to do hands-on robotics in a classroom in person. And so, as right when the pandemic started, we started thinking through, what can we do to make it possible to do robotics and to maintain the positive effects of doing physical computing for students in this new environment where you've got learning happening remotely or in a hybrid mode, or in some cases in person but socially distanced. So one solution that we came up with was this idea of remote robots. And with remote robots, the problem is, I have a robot here in Pittsburgh and I would like Terry in Alexandria to program that robot. How do we make that happen? And so we found initially a programming environment called NetsBlocks, which is based on Snap, which our robots already work in. And that NetsBlocks environment actually added some networking capabilities, the ability to send messages over the internet to the Snap programming environment. And by using that, we were able to make a setup where you could program a robot remotely via a browser that was located somewhere else. And so, this technology works with both our Hummingbird robotics kit and with the Finch robot, and it works with actually all versions of the Hummingbird and all versions of the Finch. So in the last year, we've seen people use this both for Finches and making Finch arenas where students can remotely program their Finches, and we've seen it used with Hummingbird, where you have 12 robots at a middle school that are in their makerspace, built by their teacher, that the students are programming remotely. We actually set up 5 Hummingbird robots, and Aparna will be able to put this in the chat, that you can look at and program 24/7, and your students can do that too. So please encourage them to go and program the robots that are located in my house. So to get a little bit technical in terms of how this particular version of remote robots works, you get a link, and that link has blocks for programming the robot, like Finch move forward. And when you click on that block, it sends a message over the internet to a local project running here that sends, when it receives that movement message, it sends a command over Bluetooth to the actual Finch that is located, in the studio. And so you can have 3 Finches or 3 Finch 2s connected to one computer while you make this work, to make this work. What's interesting is that you can also get the sensor data from the Finch. So the sensors on the Finch are, that information sent over Bluetooth to the local project, and then it sends that information about 2 times a second to the project that you have. And that means you can build things like obstacle avoiders or light trackers using the remote robots technology. Now it is slower than if it was running, in real time, if you had the robot kind of physically located in the same place as you. It takes about 2 seconds for a command that you create or execute or run to be visible over the camera feed, so that you can see what's actually happening. All right, so like I said, we've actually seen quite a few different ways of doing physical computing in the pandemic. And so I just wanted to take a moment to talk through some other ways that we've seen. So remote robots is what we're talking about today. You have the robots, your students don't, and you want them to be able to program them over the internet. We've also seen successful use of one-to-one robotics, which is where everybody has a robot, but you're all at home, and so you need resources to be able to teach or coach students effectively so that you can kind of virtually look over their shoulder, see what they're doing, see how their code is in progress, kind of look at what the code is. So we have adopted some tools, and we have some resources for one-to-one robotics as well as some case studies of people who've successfully implemented one-to-one robotics. So I do encourage you to check those out at some time. And then we are going to try, we've seen actually, and Terry is an example of this, we've seen people do kind of hybrid implementations where some of the students are remote and some are on site in the classroom. And so the remote students are programming remotely, like they're programming the robots in the classroom. And so are the students who are in the classroom. So it is possible to kind of merge these techniques. It's a spectrum, I guess. It's not a single method. So we kind of have to be creative in this time, I guess, is the short version of this. And people have been creative, and it's been fun to watch. All right, so I'm going to make this Finch that I have here into a remote Finch. And I'm going to use a tutorial that is now online. That is, here's the link, so you guys can check that out as well. And so in this tutorial, we have 3 ways of creating a remote robot. NetsBlocks is the first, and that's what I'm going to show you how to do today. So, to make a remote robot with Finch, to make a remote Finch robot with NetsBlocks, you need a Finch, a Windows or Mac computer, and then 1 or more webcams. So we've got that all set up. So the first step that I need to do is I need to go over to NetsBlocks and I need to open their editor. So that's editor.netsblocks.org. So this is what that looks like. And I'm going to skip this section because I've already done it, but when you first do this, you will need to create a cloud account by clicking on the cloud icon. So you'll need to create an account, and then you'll need to log in. And you want to keep track of the username that you use when you log in. All right, so once I'm logged in, and I can see that I'm logged in because it says log out when I click on this, I'm going to go down here and I'm going to take the server files and the client file for the Finch Robot 2, because that's the robot that I have with me today. So I'm first going to take the server file for Finch A. And all I'm going to do, so this opened this server file, which is a ready-made project. And this is the file that you want to run locally on your computer and have it connect to the Finch. All I'm going to do with this is I'm going to do save as. I'm going to select cloud, and I'm going to save it into my cloud account. So now this version of the Finch server file is saved in my cloud account. I'm going to do the same thing for Finch B and Finch C. In the interest of time, I'm not actually going to do it, but if you were doing this, you would do the same thing for B and C, and it's the same process. And then for the client file, now this is the file that you will be sending to your students, and you actually do want to make an edit to this file. That edit is you want to set the username to the @ symbol followed by your username. So I'm doing that right now. And then I want to press the space key and make sure that it's set, that the username is set to @HummingTom. Now, the other thing that I can do with this file is I can change what is exposed to the students. So I can change the comments. I can change, what happens in this default program. So this default program right now is an obstacle avoider, but maybe I want my default to be, draw a square. So I'm going to get rid of this. I also don't need to show them this anymore. So I'm going to get rid of the set username. I'll just move this up. And now I'm going to go to File, Save As. And again, I'm going to save this into my cloud. And I want to make sure that there's no parentheses or number after it. I'm just going to call this Remote Finch Client. I'll hit Save. And then the other thing you have to do with this file is you need to make it public. You need to make it shareable. So the last thing I'm going to do is I know this seems a little weird. I'm going to go to the file icon, hit Open. It's in the cloud, and I'm going to hit Share on the Remote Finch client. And that's good. So now this file is open. So now you're probably wondering, okay, so I've set up these files. How do I make it so that how do I make it so I can distribute this link to my students? And also, how can I test this link? So in the tutorial, there's a instruction for kind of how to edit the link. So I'm going to take this, I'm gonna put it in my favorite, my favorite text editor, which Notepad really isn't my favorite text editor, but it's what I've got. And I'm going to change your project name to Remote Finch Client. And I'm going to change your username to Humming Tom, which is my username. And now I have a link that if I open this in a new window, it should, oops. Let me make sure I actually saved all of it, there we go. It should open this project. And so this is a link that you can now distribute to your students. Now, to test it, I'm going to need to do a few things. So the first thing I'm going to need to do is turn on a Finch robot. So I'm turning on my robot here. So I've turned it on. I also want to make sure that I've put the Bluetooth firmware on the robot. So I've set it up to be used with something called the Bluebird connector. I'm going to launch that Bluebird connector. It's going to look for the robot. It's going to find the robot, and I'm going to select it. So I'm now connected, which is great. And now I need to open up that multi-Finch server file, and I need to start it. So I'm going to hit the green flag on it. And now here's the thing that can trick people up. For as long as I want people to be able to program this Finch, I need to have this browser window visible on my desktop. Now I don't have to have it like super visible, but I need to have it, at least partially visible. So like this counts, this counts as partially visible. I can see that it's running. Now, the link that I sent to other people, I can test if that's working. So I'm going to make this partially visible as well. So I want to see, does this actually work? So I'm going to try to connect to it. I'm going to hit C. And over here, it actually said connected to Finch A. So that's great. So I know that I'm connected. Now I'll just run my test program, see if it's running. And it turns out that it is. So actually, I can show you guys that. Here's my robot moving, and it's doing the test program that I set up. And so at this point, any of you could also program my robot by getting this link, which I'll just drop in the chat, or I'll send to Aparna to drop into the chat. So that robot is now running remotely. And that's basically it. Now, I went pretty fast there, but the good news is we have a tutorial where with videos that basically go through this entire process a little bit more slowly and with written instructions. I just wanted to demonstrate that once you've got it running, it's possible to set up these remote robots fairly quickly. Now, on the day of, you don't have to do all of that again, like the day that you want your students to program the robots remotely. All you really have to do is turn on the robots, connect them to the Bluebird connector, and then start up those multi-Finch server files and keep them visible on your desktop. And maybe test them, you know, with your link once or twice just to make sure it's running. So yeah, that's the quick version of how to make a remote Finch robot. So let's see, are there any questions at this point maybe we should address? This is a reasonable stopping point, and I did see that there were a few things in the chat. So Aparna, anything I need to address right now? Nope, okay, great. All right, so all right, so I think I'll turn it over to Terry, who can tell you a little bit about her setup for using these. And her setup uses actually remote Java programming at this point, but I think you started with NetsBlocks, and what you have as a setup would work equally well in both cases. So Terry, take it away.
Okay, so this is actually images from my room from a class that I had. I actually took these during class. You can see the overhead and the front view and the side view. And then I just took a picture from my camera and just so you could kind of see how the overall setup is. It's hard to see here. You'll probably see it better at my house, but there's a PVC pipe that's holding my overhead camera. And then I have a document camera sitting on the floor and another webcam off to the right. So that's kind of what that looks like. Yeah, okay. So as Tom said, this evolved as I started to do it. So I went to one of these type of webinars in the fall, and I got really excited about the idea of doing this in my classroom. I was really disappointed that we couldn't do it from afar in Java, but I went ahead and had the kids at home do NetsBlocks, and I had the kids in the classroom doing Java so that they could learn. And really, I didn't spend very much money on this at all, and it did take me a little bit of time to get set up, but I got great support from BirdBrain Technologies, and all I needed were the Finches and a little bit of time practicing and just one camera. And I did want a border for the playground. You don't actually have to have a border, but you'll end up chasing Finches all over. We use Microsoft Teams, and my kids are sharing files through Microsoft Teams that uses OneDrive. But at home, if they don't have Java loaded, it doesn't matter. They can just use a text editor as long as my computer that's running the Finches has a compiler on it. It works fine. So this is just kind of a slide. Sometimes we have to teach from home, so I did go ahead and set up at home as well as at school. I do carry some things back and forth if I want to have a complete setup at home. But you can see that the biggest expense were web cameras. IT had to buy me some web cameras so that I have more than one. And you could actually use an old laptop if your school has old laptops that will run, but our old laptops at school only had one USB port. It just didn't work. So I went ahead and got the web cameras. And because I wanted to have more than 3 Finches running in my playground, I did go ahead and get a second one running with a second dongle. But the floor is literally just bulletin board paper that we can't have up on the bulletin boards anyway. And I just used the back of it. And at home, I repurposed some tablets, and my husband made. I can show you. I think can you show my my other screen? I don't know if you can do that or not.
So
but
you may have noticed Terry's got a.
Does it show?
In her. Yeah, we can see the kind of the other screens. So
Yeah, so that's a tablet in a holder that my husband made, and that's another one. And it's just sitting on a laptop, um, a laptop stand. So it's not incredibly professional, but for what the kids see, it works great, and they can really program it. So I just wrote down kind of what I do on the day of setup, and I have to I share my room, so between every class, I have to kind of take it apart and put it back together. So I have to move the cameras into position. And then once I get the cameras connected and I start the meeting, and I make sure that I like how the cameras are set up, I just start the Bluebird connector and turn on the Finches and connect. And then depending upon which class I have in there, I have different folders that I run. So I open up the like 3 folders and run a file in each of those. And it's pretty much it. It goes really quickly. And the kids come in and they know what they're doing. Yeah, after the first day, they have a really good sense. But I did create them a document so they know what they need to do. And for the students that are in class, it's written on the board what they need to do to connect the Finches. So it does go fairly quickly.
Okay, so, we've been teasing this a little bit since the start of the webinar, but we have now created ways to run Python and Java code remotely. And Terry's been helping us beta test. So the instructions are now online. They're at that Make a Remote Finch robot tutorial. The difference between how it works with NetsBlocks and how it works with Python and Java is that it's really, the Python and Java remote robots implementation is really reliant on shared network drives. So that can be Dropbox, it can be OneDrive. Your school may have, a custom network drive setup or system. And that's because the way that it works is there's a little utility that we've created that checks if a file has changed in a folder. And if it has changed, it runs that file, whether it's a Python file or a Java file. And so the idea is that if the student is, changing a file and they hit save, that file will sync from their computer to the computer that's connected to the Finches. And then once it has synced and downloaded, it will run. And amazingly, this entire process takes about 10 seconds, maybe a little less, before you can see the robots actually running. And there's even a log file that they'll get so that they can see if they have syntax errors or other errors in case their robot doesn't run. So what this means, because of the reliance on shared network drives, is that this is ideal for classrooms or places where you can prepare ahead and share a network drive with people. It's not really ideal for doing like a drop-in workshop where you don't know who's going to show up to that workshop ahead of time. That said, I am doing a Python workshop on March 23rd, and I will be doing this remote Python programming with the Finches as part of that workshop. So if you want to see it in action in a workshop, what we're going to do with that workshop is, for those of you who sign up early, if you may have enough time at this point to request a demo of the Finch robot and get it in time. So some people will be in kind of the one-to-one robotics programming method. And then others who don't get their Finch in time will use the remote robots programming method. So again, almost illustrating like that this is actually a continuum now, that you can do both types of programming. All right, so let's do a demo. So Terry has several different camera views to show the robots at her home. And so you can actually, as a user, you can click through those. And let me do that. Let me click through them as well. So I'm going to use this view myself. It says Teresa Kelly, and it's kind of a side view of the robots. And I'm going to edit some Java code. So this is a program that's in our shared network drive. And right now it sets the beak to, you know, teal, and then it turns right. I'm going to change that to a left turn and maybe a left 90, but I'm also going to make the Finch, this is uncommented, I'm going to make the Finch move forward. So it's going to move forward 30 centimeters, turn left, and then it's also going to do some more things with the LED lights. So I'm going to save this, and I think I see Dropbox syncing. And there it goes. So again, illustrating about how long it takes. I think that was less than 10 seconds actually. And so now I got to see my code run. And if I go into the folder, I can actually pull up a log. And in my case, I didn't make an error, so it was fine. But let's say that I intentionally made a syntax error here, you know, and I'll hit Control S. And probably the robot won't run, but in a few seconds, my log should update. Let's see.
Yeah, it already tried to run.
Okay, and there it is. Here's my error. So what this means is that the students don't even need to have Java or Python installed on their laptops, and they can use any laptop. They can use a Chromebook. You do need to have a Windows laptop right now to make this work. We'll probably be able to get MacBooks working at some point. But the important thing is that the students don't really need to have any specific type of operating system. And yeah, that's a quick demo here. And I think Terry has some hints about how she runs this in her classroom.
So yeah, I found it simpler if the students are going to be using Java at home, to have them have the exact same version as I have in the class, because because there's other files that can get compiled along with it. They get a class error and it'll tell them you're using Java 15, but this is compiled in Java 8. When you give the students a test file, don't make it move forward or backward or you end up chasing fences all day. Just make it turn and show lights, and that way they know their code is working. And you'll want to have them, if you do this in your classroom, as soon as they connect, you'll want to have your students run a program to make sure that the connection is working. Sometimes, like for me, they use OneDrive. For some reason, sometimes their OneDrive gets disconnected. So that's on their end, but they only find out when their program doesn't run. So you have to be kind of upfront with them about having them make sure that they check it. When I started this, I didn't realize that my IDE and my terminal were using different paths for Java. So I couldn't actually compile Java from the command line. So that was something that I needed to check. Having flags on the Finch, as you can see in the background, they're just using the marker, and I just took some scrapbook paper and taped it on there. But it really helps them to be able to see. The first few times I did it, I didn't have that, and they couldn't tell which Finch was theirs. It is a really good idea to practice this with a student from home that's virtual, before you try to do it with your whole class, which just makes sense. And then one time, the very first time I did this from my house, I tried to do everything from one laptop. So I had my team meeting and the Finches and all the cameras on one laptop. And every time I tried to troubleshoot with the student, I had to steal the view from all the students that were at home. So it's better to have your team meeting separate from where you're running your cameras from. And these are just some common issues that I think might help you save some time. I did not realize that even my AP students do not know how to manage their files very well, especially not those with MacBooks. They don't know where any files are. So when you tell them they have to use and save the file to the cloud, they can't figure out where that file is, and they tend to download it and try to use it, and that doesn't work. And I even had one student that I finally kind of gave up on while they were virtual and said, look, just save it on your machine and upload it to the folder, because when it uploads, it'll sense the change. So if you have a lot of students with MacBooks, you might want to take a little bit of time. If you don't know how to use a MacBook, like I only have Windows machines, so I can't help them with Finder, but I did actually have some other students that can help them, so that helped. Students get errors if they try to run the program from home, so just remind them that they aren't running, they're just compiling. And then the very first day, because the students were taking a lot longer, like I don't know if you've noticed, but I've been actually running this while Tom was talking so that the Finches wouldn't time out. They time out after about 10 minutes. And it's okay for them to time out because all you have to do is go over and turn them on. But if you're trying to do other things in the class at that time, it's kind of annoying to have to go turn them on. So I actually have a program set up to run each of them. And if I know a student's working for a long time on a problem, I'll just run a small program in their folder that runs their Finch, so it won't time out. And then if they get their, if they run a program with an infinite loop, what I've found I need to do is kill the process, the run remote process that's looking for the files, and rerun it. And then if students do have a different Java version, they can delete the .class files, and then it'll compile all of them together. So those are just some things that I found that would hopefully save you some time.
Yeah, I think the infinite loops problem is the most challenging one to deal with that we haven't figured out a good solution for, because essentially if a student creates a program that has an infinite loop in it, no other student will be able to program that robot until you have to go in and kill that process. So they can't like remotely stop that program from running. There might be some clever thing we can do about it, but I haven't figured anything out yet. So yeah, so I mean, this is very early, but I think at this point it's shareable with a wider community for people to try out. And I am still very interested in getting feedback, finding out if things like infinite loops or timeouts are problems that we really need to work on technologically and deal with. So I'm hoping more people get inspired by this and start using, remote Python or Java or NetsBlocks, which has been out for a while. So let me move on, and, just wanted to mention that if you don't have a Finch 2 right now, any educator in the US can request a 60-day demo of the Finch 2. So that's that first link there. You can also purchase them in our store or sign up for the mailing list to find out, if we do come out with variations or improvements on things like remote robots. But I think at this point, we're ready to take any on-record questions. So does anyone have any questions for Terry or me or Aparna?
I have a question. What type of surface is it best for you to use the robot on? Because like me at home, I have all carpet mainly. So like, what should I do when I'm doing, because I'm still remotely. So if I want to demonstrate with my students, what should I use?
That's a great question. Let me just go back to here so you can see me. So the surface that I used is whiteboard material that I picked up from Home Depot. I think they sold like a 2x4 section of whiteboard material for, I don't know, $15, something like that. So I have two of those sections taped together. You can see the black tape lines. The nice thing about whiteboard material is you can use like washable markers and stick them in, and you don't have to worry about like constantly refreshing the paper. But like foam core or any surface like that will be fine too, I think.
Okay, thank you.
I have a question. In the new tutorial materials, what we did is we took a lot of the microbits from our older hummingbirds, because apparently when you clean them with our classroom cleaning face-to-face classroom methods, sometimes they burn out. But in the tutorial, the new tutorial, do they address like a firmware update with the link to the firmware update for the microbits if they're old?
So for the remote robots, all you need to do is put on kind of our standard Bluetooth firmware, and you should only have to do that once. And then, you know, like standard firmware kind of flashes its name. So I'm not sure if that answered your question, but like that's the only thing you should have to do to make it into to make the hardware into a remote robot.
Oh, okay, I think, well, what happened was we have some of these. This one is set up already with the update because it's giving that 3-letter code that's unique for it. The other ones, they're still flashing A's and B's. You know, you have to hit the buttons on the side because we were supposed to do an update for them.
Oh yeah, so if they're flashing like A, you know, A or B, like what you need to do is plug it into USB and download the Bluetooth firmware for Hummingbird and Finch. It's actually a combined firmware, and okay. I'll quickly get the link for that, and Aparna will post it in a second. So let me just.
Yeah, I'm sorry. You sent that to me before, and I can't find the link now.
Yeah, no problem. Let's see. Okay, doing that live is tricky apparently. Okay, looks like, let me just go to get started. Actually, you can see what I'm doing here. So I'm in Get Started. I'm going to select Windows and Snap because that's the most similar to the remote robot setup. Then I'm going to go to Program and Setup for Mac and Windows. And in here, I think step 3, you have the hex file that you want to download to your device. So I'll just put that link directly in the chat for Aparna to send to everybody. Anyone else have questions?
Hey, Tom, I just ordered, I mean, literally while you were talking, I was on my phone, a Finch. Is this, are you going to send this out as a link? I jumped in a little late because I got out of school a bit late. Can I get this as a recording so I can see the beginning of your presentation?
Yeah, absolutely. So first of all, thanks for the order. And
yeah, if you could expedite it, that would be spectacular.
Now that's Aparna can figure out if that's possible. But
all right, that'd be great.
But as to a recording, yes. So we're going to post this on YouTube and make it available for everybody to.
That's excellent. Thank you very much.
Yeah. All right, so if there's no more questions, I'm going to turn off the recording now. Again, thanks so much everybody for coming by, for learning about making the Finch remote, and for allowing us to share. I'm really excited about remote robots and the potential that they have both now and honestly in the future to allow students to connect to robotics even when they don't necessarily have the robot in front of them.